Today's lesson is on solving quadratics, and actually just about the rest of the unit is on solving quadratics. We're going to start today with two different ways. We're going to solve quadratics by finding zeros on a graph, and I'll explain what that means. And then we're going to use inverse operations that include square roots. Two different ways that we're going to solve quadratics. And what I mean by solving quadratics, if you look below, here we have standard form of a quadratic. When I say solving, it just means instead of having y equals, we're going to have a number, which is actually often 0, not always, a number in for y, and we're going to solve for x. We have to find what values of x, when you plug them into the equation, gives you 0. And in today's case, actually, all of the equations will be in this form, meaning we will not deal with a middle term at all in today's lesson. Alright, so starting out, we're going to solve a quadratic equation by finding zeros on a graph. When I say zeros, interchangeable words are also finding the roots, and really it's finding the solution. So when I say finding the solution, it's the same thing as finding the zeros or finding the roots, all interchangeable words. So in this case, we want to solve this equation, x squared minus 4 equals 0. So we want to figure out what values of x make this statement true. And I'm sure some of you immediately know the answer and what would make that true, but we're going to graph it anyway so you can see the visual representation of what your solution means. So we're just going to simply graph this equation as if it was y equals x squared minus 4. So we already know how to graph these, so we're just going to start by making an xy table. Here's my xy table, and I'm just going to plug in my values of x to find y. When you plug in 0, 0 squared minus 4 is negative 4. So 0, negative 4. There's my vertex. Plug in 1, 1 squared minus 4 is negative 3. So over 1 down 3. 2 squared is 4, 4 minus 4 is 0. So over 2 is 0. And then 3 squared is 9, 9 minus 4 is 5. So over 3 up 5. And if you remember from last lesson, because we don't have that middle term, we know that the y-axis is our axis of symmetry that cuts our parabola in half. So I just have to reflect my points over to have my fully graphed parabola like this. So my parabola is graphed right here. But now I want to use that equation to answer this question. When is my equation going to be equal to 0? So what that means is you just look at the x-axis and look at where the points cross the x-axis. They cross at 2 and at negative 2. That's where your graph is 0. That's where the y equals 0. So your solution to this is x equals a positive 2, but if you look, x also equals a negative 2. So you actually have two solutions to this, and if you look back at your equation, this should make perfect sense because 2 squared minus 4 equals 0. But if you also plug in negative 2 squared minus 4, you also get 0. So you have two solutions that work. We're going to solve another quadratic equation by graphing because in this case something special happens. Before you can graph though, you have to check to see if it's in the right form. Because we're solving quadratics means we're finding zeros, really means we're finding what value of x do you want for your y value to be 0. So we first have to change our equation. X squared equals negative 3, we want it to be equal to 0. So just inverse operations, I'm going to add 3 to both sides. So my new equation, x squared, I'm going to add 3, so it equals 0. So really all I did was rewrite the equation so it equals 0. So I'm going to graph this as if it was just y equals x squared plus 3. So once again, I'm going to make my xy table. If you plug in 0, 0 squared plus 3 is 3, so I can plot the point at 0, 3. Plug in 1, 1 squared plus 3 is 4, over 1 up 4, and then 2 squared plus 3 is 7, and that actually will go off my graph. But I can still reflect that second point over here, and then I will graph. And our solutions is always where our graph hits the 0. And you always have to look at the x-axis. Well, in this case, it never does. So this would be an example where there is no solution. And that makes sense because here, what value, when you square it, gives you a negative number? Well, nothing, because anytime you square a number, it will always go positive. Now that you know how to solve quadratics by finding the zeros on a graph, I'm going to teach you another way on how you can solve them using inverse operations. And when you solve quadratics, one thing to keep in mind, it's possible that you can have two different solutions, one solution, or it's even possible that there is a no solution. So here are 3 different examples of quadratic equations that we're going to solve using inverse operations, which includes square roots. Inverse operations just means opposite, and you've done this many times. When you have addition, you undo it by doing subtraction and vice versa, and if you have multiplication, you undo it by division. Same thing, it just means now if you have something squared, the inverse of it is the square root. So to solve number 1, we're going to start by adding 98 to both sides. Now you can divide both sides by 2. We now have that x squared equals 49. And to get x by itself completely, we have to undo the x squared, which means you square root, and you square root both sides. And the square root of 49 is 7. But 7 is not our only solution. Because if you plug in 7 squared is 49, but there's another number, when you square it you get 49. And maybe you've already figured it out, it's negative 7. Because anytime you square a number, whether it's positive or negative, you're multiplying that number by itself, and a negative 7 times itself is a positive 49. So here's an example where you have 2 solutions. Okay, we're going to follow the same steps for number 2. We're going to start by subtracting 12 on both sides. And when you do 12 minus 12 on the right side, you'll get 0. Now, to continue solving, we want to divide both sides by 3. And 0 divided by 3 is still 0, so now n squared equals 0. What number, when you square it, gives you 0? Well, you square root both sides, n equals 0. And that right there is your only solution. So here's the example where you have exactly one solution. Alright, and number 3. First step, subtract 32 on both sides. Now divide both sides by 2. And now take the square root of both sides. However, you can't take the square root of a negative number. And that is because you have to think about what value of g is supposed to make this true. What number, when you square it, gives you a negative 16? Well, that's not possible because you can never square a number and have the result be negative. So in this case, here's the example where there is no solution to solving this quadratic. One last problem solving quadratics, and it comes to you in a story problem. Suppose you begin working for a landscaping business, and one of your clients wants a circular fish pond in their garden. If they want the pond to cover an area of 250 feet squared, what is the radius of the pond? Well, think about the shape of the pond. They said circular, and they're talking about area. So, how do you find the area of a circle? Area equals pi r squared. And they give you what the area equals, and we want to find the radius. So they give you A, you want to solve for r. 250 equals pi r squared. Using inverse operations, divide both sides by pi. So r squared equals 250 over pi. I'm not going to divide it yet because anytime I'm dealing with pi, I like to wait till the very end to round. But last step to solve for r, we can square root both sides. So r equals the square root of 250 divided by pi. And you should get that the radius is about 8.92, and we're talking about feet. Well, there's your full lesson. Good luck.